They want us to find the equation of the ellipse given the center at 2, 3, one of the endpoints at 6, 3, and another random point at 4, 4. So remember, the way that you set up an equation for an ellipse is it's x minus the x-coordinate of the vertex squared all over r sub x squared plus y minus the y-coordinate of the vertex squared all over the y distance squared equals 1. So we have a lot of this information given to us. Obviously, the 2 and the 3 were given to us, but we also can find this distance, which is the x. This is r sub x, which, as you can see, that's 6, and that was 2. So 4 is r sub x. So r sub x is 4. And since we have that, we also have another point. And this point represents an xy that makes this equation true. So all you need to do is plug in the x and the y and then solve for your r sub y. So simplifying that, you get 4 over 4 squared, which is like 1 over 4, plus 1 over r squared equals 1. And now it's a matter of just simplifying or solving this for r. To do that, my suggestion is to clear the fraction. To clear a fraction, you multiply it by the least common denominator, which is 4r squared. Multiply everything by the least common denominator, distribute it in, and magically you're going to get r squared, because the 4's cancel, plus 4, because the r squared's canceled, equal 4r squared. And now I don't have to deal with fractions anywhere. So 4 equals, I'm subtracting r squared from both sides, 4 equals 3r squared. 4/3 equals r squared. And r equals, we know it's not going to be a negative, so it's going to be a positive square root of 4/3. Now the good news is we don't have to simplify that, because we're just going to plug that right into here, and it's going to be squared. So this turns into, when I square it, this just turns into 4/3. And now, to clean this up, I take the 3 and I drop it up here, and I leave the 4 on the bottom. So your answer, I'll squeeze it in up here, is x minus 2 squared over 16 plus 3 over 4 times y minus 3 squared equals 1. That's the equation of that ellipse.